Some time ago, I already tried building and flying some 4D models. It was a lot of fun as well as a new challenge. The problem though, for me, was that the entire 4D system was rather complex, at least as far as the number of moving parts were concerned, all of which had to be perfectly set up, balanced and slop-free, otherwise you just had a vibrating, jiggling, self-destroying mess. How those systems work is basically the same principle as helicopter blades, where the motor spins at more or less a fixed speed and a servo changes the pitch on the blades in one direction or the other in order to change between forwards and backwards flight. When done properly, the results can be amazing. Just check out these examples from my good friends Marcus Rummer on a giant scale but high up, or Andres Leoni on a pretty big scale, but now after years of research and development getting nice and low with a very reliable system. In my case though, I just wanted something small that I could chuck in the back of the car, go fly and have some fun with it, all without needing loads of maintenance and a load of delicate parts. That's why when I saw that T-Motor had brought out their own 4D Combo using an entirely different solution, I had to give it a go. So as opposed to changing the propeller's pitch, they're changing the motor's rotation. First off, we have the motor with a regular configuration as opposed to the more expensive traditional 4D hollow shaft used for many variable pitch propeller systems. Next up, we have the really clever part, the 3D and 4D speed controller. Basically, by pressing this button, you can switch between the speed controller spinning the motor in just one direction or in both directions. And now here's the bit that I was most intrigued about, the propellers. Of course, normal propellers have an aerofoil design, which makes them efficient at varying speeds, but they don't work well going backwards. Instead, these props have a much flatter profile, much closer to being a mirror image of itself in both directions. When intending to use the 4D system, to keep up with all of that quick reversing that this thing's going to be doing, we also need this little adapter kit, which replaces the standard O-ring for a nut-based prop shaft. Looking at all the components, we can see how much more straightforward this setup is compared to the variable pitch propellers. So let's get it all mounted into my RC Factory Crack Yak and let's give it a go. To make this even more fun, I don't want just forwards and backwards flight. I want the motor to be vector as well, so turning left and right, which gives us a whole new kind of flight envelope. So rather than just mounting the motor straight onto the front of the model, we have a small carbon plate with two ball links at top and bottom, and that's going to be the fixing point to the model, and that can then twist and turn, allowing the rudder servo to turn both the rudder and the motor, making this a lot of fun. Mounting is through just a couple of holes into which we're going to glue the ball links which hold the vector system. Once that's done, we're going to connect it up to the existing rudder servo so it controls both rudder and vector at once. To assure that the prop hub goes on perfectly straight, tighten up the grub screws little by little until fully tight. one thing though, when it starts going wrong, throttle forwards, up elevator, and it'll soon fly out. Don't try going backwards, doesn't work. There you go, a little bit of 4D with a really simple model and without all of those complex moving parts, at least for the forwards and backwards side of things. Now, it is going to take a little while getting used to this new style of flying. I personally haven't flown it for a long time, and even though I do start to feel like I'm getting back into it, it's not just pick it up and manage to hover right in front of you upside down. So, let's have a quick look at the radio first, and then we'll pop into my own little tips and tricks which I've remembered along the way. First of all, we need to understand the kind of setup that we want to do in the radio itself. The speed controller, of course, has that button which allows it to go from 3D, so just forwards, to 4D, so that's forwards and backwards, depending on whether you're on the positive or negative side of 0. Now, as we're using computer radios, personally I would always install the speed controller and have it set up for 4D. If you only want to fly 3D, well, limit the travel on the speed controller and control it as 3D, and then at the flick of a switch you can activate the full range of motion, which will then include 4D as well. Just bear in mind that 4D means that when you have your throttle stick at minimum, the plane will go backwards very quickly. So you want to have a safety switch, a cutoff. Personally, I have that here. So when that's down, the engine will never come on. I actually have on the screen here 2 positions. One of them, as you can see, is the actual speed controller, the signal that it was receiving, and then just for reference, where the throttle is. So even though I can actually move the throttle on there, you can see that no matter what I'm doing with the throttle, because my ignition kill switch is on basically, the speed controller has the instruction to stay at 0. So no movement, no prop spinning. However, as soon as I flick my cut off, then the speed controller does start receiving its signal. So from 0 up to 100. So that would be standard normal 3D flight. And then on a separate switch I have that option to increase the travel. So now from 0 backwards to minus 100, so from the centre down it's going to be flying backwards, and then from the centre forwards it's going to be flying forwards. So 0 to plus 100 for forwards and 0 to minus 100 for backwards, at least on my radio. And then at any time, if things start going wrong, flip the switch, motor turns off, and at least everything stops spinning, and it's not going to go piling into the ground or into you or the wall. That's the radio sorted. So what about the actual flying? Well, there are a couple of really good tips and tricks for 4D flying. The first of which is the centre of gravity. Unlike conventional 3D foamies that are quite happy having the CG way back, for 4D you need the CG a little bit further forwards, as we found out with our Funjet and 3D jets, who also appreciate that slightly more nose heavy CG. The reason for this is simple, because when you're doing an inverted hover, that extra nose weight helps it balance and it prevents it from spinning out quite as quickly. Now, personally, I could bring the CG further forward and that would help provide a much more stable inverted hover. However, it would be to the detriment to other parts of normal 3D flying. So I'm quite happy where it is now, but I will be trying a few more things, so stay tuned for that. The second trick is make sure to balance the aircraft really well. Now what I mean by that is this thing's going to be flying upside down with no airflow over the surfaces. So the more balanced it is to start with, the better it's going to fly, especially in those downwards hovers. So if you have to put your battery in a different place to normal, now I put it on the top here where normally it goes underneath, if you have to bring it up higher or lower, don't be afraid to do so, as the better balanced it is on its own like that, well, the easier it's going to be to do a lot of those 4D manoeuvres. And then the final really good trick is make sure to get a load of props. I've broken a couple, chances are you're going to as well. But the whole thing is holding up nicely, so don't be worried and just go out there and have some fun. Anyway, I hope you enjoyed this video. If you did, leave us a like, subscribe to the channel if you aren't already, and I'll see you all in the next one.